We do a post-mortem on our cafe latte attack and then also demonstrate the hirte attack. Let's use Wireshark to inspect test1-08.cap where we had captured what was happening with the cafe latte attack. So Wireshark. We are going to go get this file and open it. Now, in a previous video, we had already entered the WEP key, so we don't have to do that. That was the one on the fragmentation attack. So now Wireshark still remembers that WEP key, and we can just proceed to take a look and see that indeed it understands that these web encrypted frames are ARP requests and responses. If we scroll through, we see that there's lots of ARP requests and some responses. The one interesting thing is that it's asking, let's scroll this up here. It's asking for 169.254.57.242 and sending from 169.254.57.91. This is a special APIPA IP address for the case where you cannot obtain an IP address from DHCP, for example. Why are we seeing this? In this cafe latte attack, we use Airbase NG to set up a fake access point, but we did not set up additional pieces behind it. So there's no DHCP server such that when the client authenticates with and then associates with this access point, then if it's a real access point, normally then there will be a DHCP server behind it and the client can go get an IP address. So you might see something like 192.168.1.16 or something from the private IP address space. So unlike the fragmentation attack, where we inspected it before and we saw that it was using more typical private IP addresses, in this case it's not, but it's still okay because we had the broadcast and we had the responses, and as the client is broadcasting this ARP request, it's using different IVs. Even though they all look the same, they are actually using different IVs as far as the WEP encryption is concerned, and therefore eventually then Aircrack NG is able to retrieve the WEP key. We now proceed to demonstrate the hirte attack, also known as the CFrag attack. This is recommended, especially if your hardware is capable of doing fragmentation. And we can see that if we take a look at Airbase NG's help. So let's say we just do Airbase NG, scroll up. We see the options. And where is that now? -L for the cafe latte WEP attack. And it says use if driver cannot send frags. Instead, use the CFrag WEP attack, which is recommended if the driver can send fragments. This -N or CFrag for the CFrag attack, this is actually the same as the hirte attack. So we will see when we run it with -N, it's actually doing hirte. So that's a bit of something to take note, not -H, but -N. As usual, we will do RW config to see things. Okay, we already have WLAN 0 and WLAN 1, and so we can begin. We will first take a look at AeroDump NG to see what's out there. We'll use WLAN 1 here. So that will have a side effect of turning on monitor mode for WLAN 1 as well, so both will be in monitor mode. And we see that most of the channels that are used are 11, 6, and probably we should see channel 1 as well. We're just looking to see where we might have strong interference. Generally, the Wi-Fi channels, you'll find that modern access points will try to avoid interference, so you might find them starting up on channels where there's less interference. So channel 1, 6, 11. In this case, we see that the other access points out there are using 6 and 11. We don't see any on channel 1, so we'll proceed to use channel 1 for our fake access point. So we will be pretending to be test 1. So we will set up our AeroDump to be capturing that because we know we're going to be setting up our fake access point, and we're going to be using channel 1. So channel 1, ESSID test 1, write it to test 1 as usual. It might rename it to test 103, something like that. Then WLAN 0. So error dump is going to be on WLAN 0, and our fake access point is going to be on WLAN 1. We need to avoid confusing ourselves, so we have to be clear about that. WLAN 0 for our error dumping, WLAN 1 for our fake access point. And then we also have the client, the isolated client, which currently doesn't see test 1, it's not trying to connect. But later, if it doesn't automatically switch over, we will then manually have it look for test 1, and then we'll get things set up. So error dumping. And then here, we do airbase ng minus C1 minus E test 1. Minus N instead of minus L, as we mentioned earlier. And then so here we have to be careful, not WLAN 0, but WLAN 1. Otherwise we get some strange results depending on the specific hardware that we're using. But if we have two different wireless cards, then it's good to use two different ones. Okay, so this is where we'll set up our fake access point and start the hirte attack. Yeah, we've started capturing on test103.cap. But actually, let me try and get this isolated client to switch over, because it didn't automatically switch over. It was happily associated with another access point. So let me switch over to test 1. Seems there's some problem with broken SKA. Let's try switching around the Wi-Fi cards, because perhaps one of these cards cannot handle something correctly. It's very sensitive to various drivers that we're using and things like that, and the hardware chipset. So let's try this. Okay. And now I'm going to try again to connect to the fake access point with my isolated client, namely an iPhone. And this time seems to work. So the client associated with the fake access point, and now it's starting the hirte attack. Let's set up aircrack ng over here. Okay, so test 104. It's a bit slow compared with our cafe latte attack. So that's why cafe latte is also supported, because depending on the hardware you have, sometimes you see things like that. It could be quite slow. If things work out well, then you might find that this CFrag or hirte attack works faster, but well,